Alrighty, so here's our Chapter 3, Part 2, Test Review. This is all about graphing equations, linear equations. So the first one gives us an equation in what we call standard form. Okay, standard form is a number times x plus a number times y equals a number. Alrighty, and I don't love standard form, but it is good for finding intercepts. So for questions 1 and 2, we're going to use standard form to find intercepts. Alright, the first problem gives us 5x minus 2y equals 10. And it wants us to pick out the right graph. So the way I'm going to do this is I'm going to pick out the graph that has the correct intercepts. So what we've learned in class is to find the intercepts, if I want to find the x-intercept, I ignore the y term. So I do want to find the x-intercept, so I'm going to ignore the y term. When I do that, it says 5x equals 10. That means the x-intercept is at x equals 2, okay? Because we had to divide by 5 on both sides. To isolate the x variable, 10 divided by 5 is 2. So I know that I have an x-intercept of 2, and let's get that same equation, 5x minus 2y equals 10, and let's find the y-intercept. So this time I'm going to ignore x. So this x term, we're going to pretend that you don't exist, and it says negative 2y equals 10. All right, so again, to solve it, I've got to isolate the y, so we'll get rid of that times negative 2 by dividing by negative 2. And it'll say y equals a positive divided by a negative is a negative, and 10 divided by 2 is 5. So I have a x-intercept of 2 and a y-intercept of negative 5. So I need to look along the x-axis and have a dot at 2. So I know that D is not an answer choice. I know that B is not an answer choice. It's between A and C because they have the correct x-intercept. So now I'm going to check out the y-intercept. I'm going to look at the y-axis at negative 5. So the y-axis, and I need a dot at negative 5. So I know now that the correct answer should be A because it has the correct x-intercept. It has the correct y-intercept. C has the right x-intercept, but not the right y-intercept. So that's one way you could do that. You could have also taken that standard form and changed it into slope-intercept form. We'll do that on another problem later. On number 2, it's kind of similar. It's not quite in standard form. You could make it in standard form by manipulating it a little bit. If I wanted it to be in standard form, I would need that y on the same side as the 8x. So remember, if you want to shift that negative 2y to the other side, if you want to move it to the opposite side, it's going to have the opposite sign. I would have to do the same thing with that negative 10. If I want to shift it to the opposite side, it would end up being a positive 10. It have the opposite sign. So you could do that if you wanted to, and now you could use the same technique that you used in the previous question. I could find the x-intercept by making the y 0 or ignoring the y. So if I ignore the y, it now says 8x equals 10, and I could divide by 8 on both sides, and x equals 10 divided by 8 is, what is that going to be? That's 5/4, so 1.25. I could do the same thing, but for the y. Okay, I could ignore the x so I could find the y-intercept. And now it says 2y equals 10. So isolate the y by dividing, and y equals 5. So I have my x-intercept of 1.25, and the y value would be 0. And then I have my y-intercept of 5. So make sure you put it in the y spot. And we ignored the x, so that meant the x was 0. All right, guys, so that's what standard form can be used for. That's about all that I use standard form for. Cool. Next. All right, guys, on this one, identify the slope, also known as m, and the y-intercept, also known as b, for each equation or function. So on the first one, it's already in slope-intercept form, so that is great. We like that. So remember, the m is the one, it's the term it's the thing that's attached to the x. So the m is the 2/3, the slope is 2/3, and the b, the y-intercept, is the constant. So it's the one that's not attached to a number, or sorry, to a variable. So our y-intercept is 4. Cool. Now when I do part B, I'm going to give myself a little room. I'm going to bring that up here, 3x plus 4y equals 12. When I do part B, I would rather see it written in this slope-intercept form. So what I'm going to do for part B is I'm going to take that equation and I'm going to rewrite it as y equals mx plus b. So that means I've got to move over the x term right here, 3x. I want it on the right side. So remember, if I want to move it to the right side, if I want to move it to the opposite side, it's going to have the opposite sign. And that 12 was my constant. It didn't have a variable. Now there is one more little baby step. I need it to say y equals mx plus b. So I'm going to have to divide by 4 to get rid of that times 4. Now that I've done that, it does say y equals on the left side. The right side says negative 3/4 x, and then 12 divided by 4 is 3. So I put it in that form that we wanted. Now I can easily see that my m is negative 3/4. And I can easily see that my b is a positive 3. Be careful with your signs on this test. Cool. Now the next one's really easier than it looks. It says it increases by 6. The f of x, the output, increases by 6. So that's our rise. Our rise is 6 every time x increases by 3. That's called your run. Your rise over your run. So rise was 6, and our run was 3. So 6 over 3 is our slope. And then right here, I know it looks like different, but they're saying that x is 0 and that y is negative 4. So remember, when x is 0, that's your y-intercept. So our y-intercept is negative 4. Now, I could be a better teacher, and I could tell you that these are all coordinates. So this would be 0, 4, this would be 0, 3, and this would be 0, negative 4. So if I was a good teacher, I probably would have been doing that. Alrighty, the next one gives us 2 points and asks us to find the slope. So we also learned a formula, y2 minus y1 over x2 minus x1, the slope formula. So we talked in class about how we could label this x1, y1, x2, y2. And then we could just plug it in the formula, y2 minus y1. Okay, that's 10 minus 6. And that's 12 minus, and that's a negative 8. So be careful with your negatives there. 10 minus 6 is 4. And like we talked about in class, a minus a negative becomes a plus. 12 plus 8 is 20. So 4 over 20, or you could reduce it. If you divide both of those by 4, you'll get 1/5, 1 over 5. All right, here we go. We could do the same thing here. We could talk about y2 and y1 and x2 and x1. I could do that, or I could just say, all right, what's my rise? How are my y's changing? My rise is I went from negative 2 to 0, so I went up by 2. And you can see it keeps going up by 2, up by 2. So our rise is 2. Now let's look at our run. Went from 3 to 4, from 4 to 5, from 5 to 6. So our run was 1. So our slope is 2 over 1. Cool, cool. And now this one was the one where we had to keep the pattern going until we could find our y-intercept. Remember, your y-intercept is where the x value is 0. So I'm going to tweak this a little bit. So we're going to keep this table going a little bit. All right, so let's keep it going. 3, 2, 1, 0. So we're going to keep this table going until the x values get to 0. I've got to keep that pattern going. Okay, I saw I had 4, and it went down to 2, down to 0, down to -2. Do you know what's going to come next? I hope you said -4, and then -6, and then -8. And then there, right there, when x is 0, y is -8. So my y-intercept is -8, or I could be a good teacher and write it as 0, -8. All right, guys, that probably will be the hardest part of the test. Cool. Let's keep moving. All right, guys, I really like the way we did this in class. We talked about the Hooivaks. All right, we talked about how horizontal lines have a 0 slope, and their equations are going to be y equals something. Y equals stuff. Y equals a number. We talked about how vertical lines, okay, so that's up and down vertical lines versus the horizontal. So we talked about how vertical lines have an undefined slope. The slope m is undefined. And their equations are going to be an x equals stuff. X equals a number. All right, so that's what we learned in class. We're goofy about it, but that's it. So let's see what we got here. M is undefined. So I know automatically that that's going to be the vux. That's going to be the vertical line one, which is equation B. M equals 0. Well, that's going to be the Hoy one. M equals 0, so that was equation A. Y equals 2, that's going to be a y equals stuff, so that's going to be the horizontal line, equation A. X equals stuff, that's going to be the vertical line, so that's going to be equation B. And the intercept is 0, 2, so 0, 2 is equation A. And 2, 0, that's a dot, 2 on the x-axis, so that's equation B. All right, so that question is a lot easier if you understand our little shortcut here. All right, up next. So this is still your y equals mx plus b. It just looks a little funky. All right, we know that the m, the slope, is still the one connected to the independent variable. The b, the y-intercept, is still the thing that's that has no variable attached to it, and the y is the output or the dependent. And we know I don't know if we said it already, but the x is the input. Or independent. All right, so the first thing says the independent variable is, well, that's going to be the variable here, b. It's kind of like it would be the same thing as the x. And the dependent variable, the output, is p, the one that's on the side by itself. The slope, okay, remember the slope is the one that's attached. It's attached to that variable. So our slope is -8. And interpret it in context. Well, that means the slope's negative, so something's decreasing. I guess as I bag up the leaves, there's less pounds that are left to bag. The pounds of leaves are decreasing. Something like that. The y-intercept, the b, all right, that's the thing that's by itself there, the constant. Our constant on this one is the 80. So that means I started with 80 pounds of leaves. And is it discrete or continuous? Well, that depends. Can we have 0.5 of a bag, 2/3 of a bag, fractions or decimals of a bag? And no, you can't go to the store and buy a box of bags that says, hey, there's 23.2 bags in here. No. So we're going to go with this as a discrete. And the reason is because we're saying you can't buy partial bags. Continuous means we can have decimals, we can have fractions. Okay, but discrete means it's got to be all whole numbers. Or maybe not necessarily whole numbers, but there's things it can't be. All right, so part B on this test was all about transformations. So remember, I don't really care what f of x is. I don't care. I just want to know what I did to f of x. So we multiplied it by 3. So it's like stretching it. That's like making it taller and skinnier. We call that a vertical stretch by a factor of 3. So no matter what the function is, let's go with a square, a quadratic function. If I throw a times 3 in there, it's going to make it taller and skinnier. So the parent function, y equals x squared, would look something like this. But when I multiply it by 3, it's going to get skinnier. All right, so that's called a vertical stretch. Up next, choose the correct transformation. Again, I don't really care what f is. I want to know what I did to f. I added 2 on the end. So that would be me taking the function and just raising it 2 units. So that would be a vertical shift up 2 units. Another example, y equals x squared. Okay, and then that would look like y equals x squared, look like that. But if I tagged a plus 2 on the end, y equals x squared plus 2, it would take the same exact graph and just move it 2 units higher. Just raises it up 2 units. It's called a vertical shift up 2. Up next, oh, okay. So the original function looks something like this. This looks like what we did in class. And then we flipped it over the x-axis. So if we flip it over the x-axis, that's because we just put a negative sign in front of the whole thing. So that would be not a stretch, a reflection over the x-axis. That's what that would be. Because the original function was on top of the x-axis. All right, number 9, fill in the blank. Reflect over the x. What is going on here? I want to reflect it over the x-axis. All right, then let's throw a negative sign in front of it. I want a horizontal shift 2 units left. So 2 units left means that this has to say x plus 2. Because when you deal with your x, it's always the opposite of what you think it's going to be. Vertical shift up 4, that means I need a plus 4 at the end. Sorry, 4 units down. So not a plus 4, a minus 4. And a vertical stretch of a 3. So that's not just going to be a negative out here. We're going to put a negative 3 out there. So what this would look like in a prettier way, f of x equals negative 3 times the absolute value of x plus 2 minus 4. So one thing at a time, okay? One thing at a time. Reflection over the x-axis, That's where that negative sign came from. Shifting left 2 units. This is what's telling me to go left 2 units. Remember, it's dealing with the x, and your x deals with your left and right. 4 units down, so it needs a -4 at the end. And then lastly, a vertical stretch of 3, make it 3 times skinnier. There we go. So each piece has a function, each piece has a job to do. All right, last up is Rufus going for a walk. All right, what's going on with Rufus here? All right, so I'm definitely going to be talking about intercepts and where he starts. He starts at 2,000 feet. So his starting point is 2,000 feet away, judging by his starting point there, 2,000 feet. I could also talk about the x-intercept. I guess he gets back home after 12 minutes. So he starts 2,000 feet away, 2,000 feet away, and it takes him 12 minutes to get back home. All right, so let's see which answers make sense. After 12 minutes, Rufus is 0 feet from, yeah, because that's true. Rufus is back home after 12 minutes. That's the x-intercept, the x-axis, the x-intercept. So number 1 explains the x-intercept. Number 2, after 24 minutes, Rufus is 2,000 feet from the back of the... That's also true, but it doesn't have anything to do with the intercept. Oh, I put the other thing in the wrong spot. There we go. That's better. When Rufus gets back to his house, he's 2,000... No. When Rufus begins his walk, yes, that's a y-intercept. Where he begins, that's y-intercept action. He is 2,000 feet. So yes, that number 4 explains his y-intercept. Cool. Well, that's our test review. That was a 22-minute video. If you know all this stuff, you should rock this test, okay? Good luck.